All right, 2.7 is graphing techniques. So the general form for a parabola, that we're going to be working with, I don't want to just say in general for a parabola, but is f of x equals negative a times x minus h squared plus k. And so each of these things, is, aside from the x, is telling us what's happening to our graph. And so when we do problems like this, the whole point of the section would be to actually be graphing these. But I just want you to tell me what's happening. Okay, a general parabola looks something like this. It's a U. That wasn't a good one. Something like that. It's a nice U. Anyways, that goes up. But if it's written in this form, that means it's been shifted around, it's been compressed, it's been stretched, different things. And so I would hope that by knowing what's happening, you would also be able to graph it. Okay? I'm going to actually put here, this is plus or minus. It doesn't have to be minus, just for the sake of what we're about to write down. So, anyways. So inside here, inside the parentheses, this minus h tells us that we are moving to the right. If instead it's written in the form plus h, that means we're moving to the left. So my little helpful hint here is inside the parentheses, go opposite direction of the sign. Because generally we would think of as negative as being to the left and positive as being to the right, but inside the parentheses they are opposites. Now, outside of the parentheses, so the k, it goes the same direction. So plus k is up, minus k is down. So I write outside the parentheses, go the same direction as the sign, or of the sign. So if A is negative, it is reflected. Just meaning that the graph has been flipped upside down. And that can also just be like A can be 1, so it's not written, and it just might be a negative sign out front. That just is telling you that it's reflected. All right, then the last thing is A, which I said just a minute ago could be just like 1, which would be the baseline. If it's just 1, that's like nothing is happening. It just looks like this. But if the absolute value of A, and notice I do that because a lot of people get confused and start thinking, oh, well, the negative sign or whatever. We're looking at the positive number value. If the absolute value of A is less than 1, okay, meaning essentially that it is a decimal, a fraction, something like that, then it is compressed. And if the absolute value of A is greater than 1, it is stretched. So if I had like -3 for A, that's bigger than 1 when I take the absolute value, because that would be 3, so that's stretched. But if I had 0.75, that's less than 1, so it's compressed. Okay, so in here, it's like a fraction, decimal, etc. I need my book. Any questions about that before we get started with examples? Alright, so I modify the instructions on these problems because, like I said, they actually have you graphing them, but I don't do that. And just so you know, I mean, we're primarily working with the parabolas as far as this section goes. I'm not really doing a whole lot of, we're going to do one that's like an absolute value, but this works the same way as like if we have the absolute value, okay? All of this would be the same if I had a basic absolute value function like plus or minus a times the absolute value of x minus h plus k like this. All of these rules still apply. Works the exact same way. Okay? We treat what's in the absolute value bars like what's inside the parentheses. Okay? If we had cubing function, so like more or less the same as this, but it's cubed, it's going to work the same way. So something like plus or minus a times x minus h cubed plus k works the same way. And then the other one that we could have is a square root. So anytime we have a square root, anything inside is treated like the parentheses. So f of x equals plus or minus a times the square root of x minus h, and then plus k outside. So all this stuff in here is treated like the parentheses in what we did up above. Okay, otherwise everything else is exactly the same. It's just in terms of which function. Obviously the graphs look different, but all I'm asking you to do is to tell me about the shifting that's happening. And something else, which we'll have some examples that have this, but if you have something like x squared plus 2 and there's no parentheses, that plus 2 is the k value, okay? So that means it's not shifted right or left, it's just moved up, okay? So just so you can see an example of that, actually number 60 is like that, which is f of x equals x squared minus 2. So this one just has an a value of 1, okay, because there's nothing out front. So it's just like an imaginary 1. So nothing's happening in terms of being compressed or stretched. It's not negative, so it's not reflected. There's no parentheses, so it's not moving right or left. The only thing that's happening is what I would say is outside the parentheses, there's a minus 2, so that is going to be going down 2. 64. G of x equals, in parentheses, x minus 2 squared. So this one's inside the parentheses, and it's a minus 2, so which direction is this going?
Right 2.
Yep, inside is opposite, so this is right 2. Do a different kind of function this time. G of x equals the absolute value of x plus 3 and then plus 2 outside. Okay, so this one has more stuff happening to it. We treat the absolute value bars just like we do the parentheses in a quadratic function. So the plus 3 inside tells me I'm doing what? Yep, left 3. And the plus 2 outside tells me I'm going where?
Up.
Yep, up 2. Let's see, 70. H of x equals negative, parentheses, x minus 1 cubed. All right, so what's happening with this one? Remember, even though it's a cubic function, it's the same thing, same rules as the quadratic function. Let's start with this. What does the negative out front tell me I'm doing? Yep, reflected. And what does this minus 1 tell me I'm doing? Right 1. And notice, this isn't compressed or stretched because the absolute value of this number in front would just be 1. We're only looking at if it's less than 1 or greater than 1. 72. H of x equals 3x squared minus 2. So now I have a number in front of x squared. Is that greater than 1 or less than 1? Greater. So which thing is that? Stretched or compressed?
Stretched.
Yep, stretched. It's greater than 1. What about this minus 2 out here?
Down 2.
Yep, good. Down 2. So there's no parentheses, so that tells you that it's moving either up or down. In this case, it's down. Let's see, 74. We got a little bit more going on in this one. F of x equals negative 3 times x minus 2 squared plus 1. We've got several things happening with this one. So it doesn't matter what order you tell me stuff. What's happening here? It's reflected because of the negative out front. Yep, stretched because 3 is greater than 1. Or negative 3, the absolute value of that is greater than 1, however you want to think about it.
Right 2.
Right 2. Last thing, up 1. So that problem kind of gives us the whole deal there, everything that we could possibly have to write about it. 76. F of x equals the square root of x minus 3. So notice everything's under the radical here. So what's happening to this one?
Right 3.
Yep, right 3. Let's see. Let's look at 2 more. 80. F of x equals 3 times the square root of x, and then outside minus 2. What about this one?
Down 2.
Yep, down 2, and one more thing. Yep, stretched. Apparently 3 is a popular number. 3 is greater than 1. All right, and then let's see, one last one. 82. G of x equals 1/2 x cubed, and then plus 2. So what do we have going on with this one?
Compressed.
It is compressed because there's a fraction there. Makes it less than 1. And what about this plus 2?
Up 2.
Up 2. Now, if this fraction had been 5/2 instead, what would it have been? Stretch, because it's greater than 1. So make sure you pay attention to that. That's why sometimes I'm hesitant to write if it's a decimal or a fraction, because sometimes then people are like, well, it's 5/2, that's a fraction. It's like, yes, but it's greater than 1. So a fraction that is less than 1, or a decimal that is less than 1 is what we're talking about. So, but apparently I can't trick y'all, so. All right, problem 61, 65, 69, 73, 77, 81, and 85. So, again, the instructions say to actually graph it. We are not graphing. You are just doing what I did of just telling me what the translations are. Essentially, I will just, like the instructions will say, compare it to the graph of the parent function and explain how it's being translated or something along those lines, is just so you're aware of what that would look like in this.